Wally, you're packing a glaze kiln there.
Yes, this is very different from the biscuit firing you just saw packed. In this case, not only do the glazes melt in the firing, but the pots themselves vitrify. That is, the clay particles start to fuse together. The pots themselves actually begin to melt. They can even deform under their own weight under these conditions. These shelves that we've used here to support the pots and keep them apart. Because the clay is vitrifying, they're beginning to melt in the firing, we have to coat it with a layer of alumina. This is a white powder that doesn't fuse in the firing and separates the pot from the shelf.
Yes, of course, no pot must touch.
No, the pots are kept apart because otherwise the glaze would fuse them together.
Right, well, what do you think the main difference is between this, say, and earthenware firing?
Well, in earthenware, the clay doesn't vitrify. It remains much more stable, and this means that we can glaze right the way across the bottom of a pot and support it on 3 little points on a stilt like this. This means that the glaze just fuses those 3 little points onto the pot, and that can be broken off and the little scars cleaned up afterwards.
Yeah. Then what method of telling the temperature are you going to use in this kiln?
Well, we're using cones in this case. Now, the cones are made from the same sort of materials as the pots, as the glazes that we've used on the pots. And they melt at predictable temperatures. The first one here will fuse at about 1250 degrees centigrade. That gives us some warning that we're near to temperature. The middle one's a 1280 cone. That tells us that we're just where we want to be. And the last one acts as a guard. We want that one to remain standing so that we don't overfire. This kiln's been firing for about 4 hours now.
There's about 6 or 8 hours to go.
Yes, it's quite a long way to go yet. But have a look and see what temperature it's at. Yes, you can see that the cone in there that's bending indicates that we're at about 1000 degrees centigrade. The other cones will bend later on, of course.
We've seen how the kind of clay body you use affects the appearance of the glaze. This was our original glaze of 85 feldspar, 15 of whiting, and I've had it in this case in an oxidized firing in an electric kiln. Here's exactly the same glaze, but this time it has been fired in a reduction firing, in a gas kiln this time, and you can see that the glazes are very different. In the case of the reduced version, we have quite a lot of speckling on the glaze, a rather more interesting surface, and certainly a darker colour. The oxidized version, on the other hand, is very much cleaner looking and paler in colour.
Lynn, tell us some of the other things you can do to alter glazes.
Well, simply you can add other ingredients to the glaze. We've only got 2 in it so far. We'll have the first look at colour. To make colour, the simplest thing to do is to add what we call metal oxides. We'll have a look first at iron oxide.
A kind of rust, is it?
Yes, this is a very commonly used one.
Yes.
And the kind of colours we get from this are basically yellows and browns. What I've done, in fact, is taken the original glaze. This was our base glaze, and to it I've added increasing amounts of iron oxide, ranging from 0.5% through to 18%. And the colours that I get in the oxidized firings range through yellows and eventually to dark browns. The reduced version gave pale blues and greens as opposed to the yellows of oxidation, eventually browns at 18%.
18%?
Yes, it's quite high, isn't it? And it's interesting because not only has that high iron content changed the colour of the glaze, it's also changed the surface. It's become very much matter now. You can see that using colouring oxides isn't quite as simple as using paint box colours.
Yeah, I think you're right. And in fact, if you look at this group of pots here, these 2 are oxidised. This Sally Dawson teapot with the light body. All the rest are reduced. And in fact, some have very much less iron in than others. This little Celadon goblet of mine has only 2% iron in it, whereas this dish by Colin Pearson with its lovely pinky blush on it has a little more iron. These 2 pots, this large jug of mine, and this beautiful dish by Ray Finch with its lovely bottle browns and deep greens, they have even more iron in them. And in fact, those 2 are what we would call temokus, a Japanese word for an iron-bearing glaze. Many potters have their temoku glazes.
Another colour. This time we'll have a look at cobalt oxide. Here's the powder form, a very black powder, but in fact the colour that we get from cobalt is blue. Very important thing to know about cobalt is the strength of the oxide. You see that only 0.1% has given us quite a reasonable blue, and I've only had to go as far as 2% of cobalt in the base glaze to get this very dark blue.
Very powerful oxide.
It is a very powerful one. And interestingly, the reduced and oxidized versions are very similar, so it's quite a stable colour.
Yes, I think you'll see on these two pots here, this blue on this Eileen Lowenstein pot on porcelain body, and this blue on this reduced pot by Robin Welsh are still nevertheless blue. I mean, if there is a difference in colour, it's probably derived from the body, but they're still blue.
Yes.
Now, another one.
Well, another one, copper, a black oxide again. And in this case, the oxidized and reduced versions are very different, unlike the cobalt. Here are base glazes again. And the additions this time range from 0.5 up to 7%. And the colours that we get here, in the case of oxidized glazes, range through light green to dark green, eventually a rather metallic green. And in the case of reduction, we get very beautiful pinks and reds. Now, these pinks and reds in reduction are really rather difficult because they're unstable, and you might find sometimes that the red you want comes out rather tinged with green, as in the case of this one.
Yes, it's a very dramatic oxide.
It certainly is, and in fact sometimes if you put a copper-coloured pot into a kiln, the surrounding pots can come out tinted with the copper colour. It seems to spread all around the firing.
Yes. If you look at these two copper pots, for example, here we've got the difference. There, the Colin Pearson dish is a mottled pinky plummy colour, whereas this John Parker bottle is a rather mottled turquoise. So it's a question of doing lots of trials.
Yes, very important. In fact, I think a lot of potters tend to put a few glaze trials into every kiln they fire.
Yes, I do. I have a trial in every kiln. They don't always go right, but at least I record them and I can take account of what's happening to these defects. In fact, I think Wally's got some pots there and some strange things have happened to. Lynn,
yes.
what do you make of that one?
Well, this is a defect called crawling, and what's happened is that the glaze has beaded up on itself and left bare patches of clay.
Amazing.
Yes, I think it may have been caused by the fact that the glaze was applied too thickly, or perhaps the biscuit pot before glazing was rather dusty or greasy, and so the glaze couldn't stick properly to the pot.
Very spectacular. What about
Yes.
that one, Wally?
Well, this one's one we're all familiar with, I think. It's crazing. Lynn, what
yes.
can you tell us about crazing?
Yes, this is a very common defect. It occurs when the clay and glaze haven't shrunk to the same extent in firing. In fact, in this case, the glaze has contracted far more than the clay of the pot, and so the glaze has cracked. The only way to cure this is to alter the composition of the glaze.
It's a very interesting effect, and of course it may mean that one man's defect is another man's special effect. And if we look now at some ancient pots, we'll see how some of these faults have been used to very great aesthetic purpose. To take an example, this may look like crawling, but what's actually happened to this little pot, probably an English 17th century bottle, it's been salt glazed. That means that at the height of the stoneware firing, salt has been thrown into the flames of the firebox. The salt volatilizes, combines with elements in the clay, and forms a glaze. It goes everywhere, forming this brown, mottled, slightly orange peel effect. It goes all over the kiln, all over every pot, fills up all the crevices in this crest, goes on to the bearded head here. Some people call them greybeards or beramines. It covers every surface. By contrast, this chun bowl from Sung, China of the 12th century AD, you may wonder, was that splash a mistake? I don't believe so. It's copper, reduced copper, that's why it's red. But the glaze is blue. Now, we've said that cobalts give you blue, but there's no cobalt in that glaze. It's one of the really magical effects of glazing. It's an optical blue, blue light. This little Sung bowl, the Sung potters were some of the finest in the world. To modern technologists, this may seem full of mistakes, because the iron and the sulphur have boiled and blistered and produced craters over the surface. But eventually they've settled down to give these oil spot effects. This last dish is very different. It's earthenware from Spain, part Christian, part Islamic. And it's had two glaze firings. The second firing a smoky, hazy reducing firing, has been used to make the copper painting on the surface reduced to this lustrous, bronzy red colour. We call this a Spanamoresque dish.